Good evening everyone. I welcome you all to Ganesh IAS Academy. In today's session, we'll be seeing environment-based current affairs from the date March 19 to March 27, 2024. Let us get into the news articles one by one. The first news that we are going to discuss is about biomining. Why is biomining concept or the process is in news? And what is the process behind biomining and what are all the different steps that are involved in biomining. All these details we must have to understand. Let us get into the details. Delhi's biomining project to clear landfill sites is likely to miss the latest deadline of 2024. So, Delhi's biomining project to clear landfill sites is going to miss its latest deadline, which is 2024. That is the reason why it is in the news. So, from exam point of view, what all do we have to know? What is biomining? What is the process behind it? And what are all the different steps that are involved in biomining? This is what we are going to understand here. What is biomining? It is a scientific process of excavation, treatment, segregation and gainful utilization of aged municipal solid waste. The point to be highlighted here is aged municipal solid waste that are lying in the dump sites. Okay, so these aged municipal solid waste are also called as legacy waste. Okay, so the legacy waste will be excavated, treated, segregated and then it will be gainfully utilized. This process is called as biomining and there are 4 steps involved in this biomining process. The first step is obviously excavation of the legacy waste. Next is stabilizing the waste utilizing bioremediation. So the second process here is bioremediation. Third process is after bioremediation, the solid waste has to be segregated. Okay, so the third step here is segregated of excavated waste, and then the final step is sustainable management and its safe disposal. So the waste that has been segregated has to be sustainably managed, and then any other waste that is generated as a byproduct of this process should be disposed properly. So these are all the steps that are involved in biomining. What else do we have to understand? There are 4 different methods of biomining. The first method here is bio-leaching, and then comes bio-oxidation, dump leaching and agitated leaching. All of these different methods have different applications. Okay, in certain processes bio-leaching is used, in certain other processes other 3 are used. So what are the details of these processes, these methods? Let us understand one by one. So the first process that we are going to discuss here is bio-leaching. What is bio-leaching? It is a method which involves dumping low-grade ore into a heap called as leach pile. So low-grade ore will be taken and then it will be piled up as a heap. Okay, and that is called as leach pile, and then it is soaked into a weak sulfuric acid wash. So it is soaked into a weak sulfuric acid wash. What is the reason behind sulfuric acid wash soaking? Okay, it is that the acid will react with the ore's sulfide matrix. So if there is a sulfide matrix in the ore, then this acid will react with that sulfide matrix and it will encourage the growth of bacterial strains which will start to degrade the ore and release minerals or metals in the fluid form. So the ultimate aim here is to degrade the ore and then extract the minerals and metals that are hidden inside the ore. Okay, so this is how it looks like in a microscopic view. Okay, so this is bio-leaching process where bacterial growth is allowed with the help of soaking it in sulfuric acid. This is what bio-leaching is. The next method that we are going to discuss is bio-oxidation. So this method is widely used for extraction of gold. There in bio-leaching, it is generally minerals and metal extraction. Here it is very specifically, it is used or widely used for extraction of gold from ore, and then the ore is exposed to bacterial oxidation again. So even here bacterial action is needed, bacterial oxidation is happening which degrades the insoluble pyrite and arsenic components that are to be removed. Okay, next is dump leaching. What is dump leaching? It is again an industrial process which is there to extract precious metals and copper from ore. So dump leaching is for precious metals and copper ore. And then comes agitation leaching, which is a chemical process which is used to extract mineral from the soil. So extraction of mineral from the soil is agitation leaching. So these are all the different methods that are involved in biomining. Okay, and each has various applications, different applications. What else do we have to understand? That this biomining process is a solid waste management tool. How is this a solid waste management tool? That is because it is used to clear oil spills in the sea and also to clear pollution from soil, groundwater, surface water and air. So to clear pollution and also to clear oil spills in the sea, this biomining process can be used. And then it is also used to degrade environmental contaminants into less toxic or non-toxic forms. So these environmental contaminants has to be converted into its less toxic form, then only it is useful. So this biomining process is used here, and it can also be used for wastewater treatment, industrial waste, hydrocarbon contamination and treatment of agricultural chemical waste. In all these processes, biomining can be used. Thus, it is considered to be a tool for solid waste management. And then, what are all the benefits of biomining? This biomining allows for recycling the resources. So, recycling any resource is an important aspect. Okay, so recycling resources by extracting useful components from the waste, and then it is eco-friendly and environmentally sustainable. These are the benefits of biomining, but there are certain disadvantages of biomining also. What are they? That only biodegradable compounds can be degraded with the help of biomining techniques. So it is restricted only to biodegradable compounds, and it takes time to show results. That is also there. Immediately we cannot gain the results, or the degradation will not happen overnight. It will take time. Next is, there is a risk of leakage. That is also there. That is because we are using acid. Like we saw in bio-leaching process, we were using sulfuric acid for degradation process. So it is treated with acid, and then metal rich solutions are also there. If this leaks into the environment, then that will again pose a serious threat. So these are all the problems that are there, or the disadvantages that are there for biomining process. So this is what we need to understand from this particular topic, that is biomining. The topic that we are going to discuss now is International Partnership for Hydrogen and Fuel Cells in the Economy. What is this related to? Let us get into the news. Recently, the 41st Steering Committee meeting of the International Partnership for Hydrogen and Fuel Cells in the Economy, IPHE, it was hosted by India in New Delhi. That is the reason why it is in the news. So with this news background, we must have to understand about the details of this organization and what is this organization doing, that we need to understand. Okay, so what is this organization? IPHE, International Partnership for Hydrogen and Fuel Cell in the Economy. Okay, so it is an international intergovernmental partnership, and it was established in the year 2003, and it consists of 23 member countries and European Commission. And of the 23 member countries, there are major economies like United States, Japan, Germany, China, South Korea, Canada, and even India. Okay, and what is the mission of IPHE, that is International Partnership for Hydrogen and Fuel Cell in the Economy? What is its mission? It is to facilitate and accelerate the transition to clean and efficient energy using hydrogen and fuel cell technology across application and across sectors. Okay, so this is what is the mission of IPHE. So now we need to understand the details of hydrogen, and specifically they are saying clean hydrogen. Clean hydrogen here is the green hydrogen. So we need to know the details of green hydrogen and what are all the different derivatives of green hydrogen that can be used. Okay, so now let us get into that detail. Green hydrogen, it is also known as GH2, okay, green hydrogen, and it is produced using renewable energy source, okay. So if hydrogen production is going to happen with the help of renewable energy sources, then simply it is called as green energy, okay, and it is considered a key element for deep decarbonization of the energy mix. So if we have to go for deep decarbonization of energy mix, then we have to go for the route of green hydrogen, that is through renewable energy sources hydrogen is being produced, okay. So this is what is going to happen in the hydrogen production. This is simple electrolysis of water, okay. So the process involved here in green hydrogen production is electrolysis of water. What is electrolysis? Electro is using electricity, and what is lysis? Lysis means to split something into two, okay. Anywhere you see this term lysis, then you can understand that something is getting separated or it is being split, okay. So here what molecule is going to get split? It is water molecule. So water molecule here is going to get split into hydrogen and oxygen. That is why it is called as electrolysis of water. So in the electrolysis of water, you are getting oxygen and then you are also getting hydrogen. Anode reaction and cathode reaction. This is how it happens, and there is a membrane in between. Typical electrolysis process which involves electrodes, okay. Next is, there are certain derivatives of green hydrogen like green ammonia and green methanol, and they are long-term energy carriers that store surplus renewable electricity produced during the period of low demand. So there are derivatives of green hydrogen like green ammonia and green methanol. So we need to understand the details of it because they are being used as an energy source because they store surplus renewable electricity, okay. So now let us understand the details of what green ammonia is. Green ammonia is produced from renewable energy sources. Again, the term green means it is produced from renewable energy sources, and it has potential to play an important role in reducing the world's dependence on fossil fuels. Obviously, this is an important benefit of green ammonia. Anything green is going to reduce the dependence on fossil fuel. So how does the process go? There are two units. One is separation unit, another is electrolysis unit. Electrolysis unit, in the previous slide itself we discussed that water is going to get split into oxygen and hydrogen, and thus hydrogen, green hydrogen is produced, and they are going to use renewable energy for it like windmill, solar energy, hydel, all these. So electrolysis, it gives hydrogen. Next is another separation unit where nitrogen is produced. So from air, nitrogen is separated, and even for this they are using renewable energy, thus nitrogen is produced. So nitrogen and hydrogen, we have these two. It can be synthesized into ammonia because ammonia is NH4. Okay, so NH3. So green ammonia is produced here, okay. So this is how it happens. This is green ammonia. Next is green methanol. What is green methanol? It is a key product in the chemical industry. In many chemical industries, methanol is being used, okay. And then it can be used to produce other chemicals like formaldehyde, acetic acid and plastics, or it can even replace methanol as the main compound here, okay. So how is this produced? We have green hydrogen, same electrolysis process. Electrolyzer is used and then renewable energy sources is used. Green hydrogen is there. Next, we are going to introduce carbon dioxide from the atmosphere. So it is directly captured from the air and then it is synthesized. So synthesis of e-methanol, okay. So what we are getting? We are getting methanol, CH3OH, okay. So it is H2 plus CO2 which gives CH3OH, okay. So green methanol is ready and then it is being used for many other purposes. So this is what we need to know from this particular topic, that is green hydrogen. The topic that we are going to discuss now is Plastic Waste Management Rules 2024. So earlier plastic waste management rules of 2016 was amended. So that is why it is in news. Let us get into the details of it. Ministry of Environment, Forest and Climate Change of India has recently introduced amendments to the plastic waste management rules of 2016 through this plastic waste management amendment rules of 2024. Okay, so this year we have new set of rules. So these changes signify a significant effort to address the plastic pollution that we have in India, particularly by targeting microplastics. So here we need to understand what is microplastic and setting stricter criteria for biodegradable plastic. So here we will be understanding about the details of biodegradable plastic and how is it different from compostable plastic. Okay, so all these details we will be understanding, and then we will also know the key findings or the key highlights of this rules. Okay, key highlights of the latest plastic rules. Okay, so biodegradable plastic, and they have defined what biodegradable plastic is. Okay, that is one important aspect of it. So the materials that are capable of degradation by biological processes in specific environments like soil and landfill without leaving any microplastics is known as biodegradable plastic. So after the completion of biodegradation, there should not be any microplastics left. That is the aim here. So now a question arises, what microplastic is? Microplastic is defined as any solid plastic particle which is insoluble in water with a dimension between 1 micron and 1000 micron. So any plastic particle with a dimension between 1 micron and 1000 micron is called as microplastics, and in recent years these microplastics have reported a major source of pollution which is affecting many water bodies like rivers and streams. Okay, now we need to understand the details of different types or the different categories of microplastics that are there. Okay, we are seeing the findings or the key highlights of the plastic rules 2024. So here the microplastic is categorized into two: primary microplastic and secondary microplastic. What is primary microplastic? These are tiny particles which are designed for commercial use. So they are designed in that dimension. Microplastics which are designed in that dimension, that is 1 micron to 1000 micron, is primary microplastics. And then they are also microfibers which are shed from clothes and textiles. Those are also included here, and the best example here would be microbeads which are found in personal care products, plastic pellets and plastic fibers. These are the best examples of primary microplastics, which means they are synthesized for this purpose. Next is secondary microplastic. Why is it secondary? That is because it is formed from the breakdown of large plastics. So they are not designed to be microplastic, but here they are designed to be microplastic. But here it is breakdown of large plastics such as water bottle, which is caused by exposure to environmental factors like sun's radiation and ocean waves. If a large plastic like water bottles are being exposed to sun's radiation or they are continuously facing ocean waves, then it might lead to release of microplastics, which is secondary microplastic here. Okay, and then these microplastics are dangerous. That is because they act as a carrier for chemicals, antibiotic resistant bacteria, pathogens, and thus it poses risk to aquatic life as well as human health if they bypass the water treatment process. So every other water that humans consume has to be processed. Okay, so water treatment processes are important here. Next is coming to the highlights of the rules. The next one is expanded definition of importer. Here the importer's definition has been expanded. How? That is because earlier importer referred to someone who imported the plastic packaging, products with plastic packaging, carry bags, multi-layered packaging, plastic sheets or similar items. This is how the earlier definition was, but now in the new rules they have expanded its definition. How? Now it includes imports of various plastic related materials. So all plastic related materials are included, like packaging, carry bag, sheet, and even raw materials and intermediate materials are used. Earlier raw materials and intermediate materials were not used, but here it is used, okay, that are used in the plastic manufacturing for commercial purposes. So this is the way they have expanded the definition of who is an importer. Next is inclusive definition of manufacturer. So the manufacturer's definition is also, has also made inclusive. How? The scope now encompasses those engaged in production of plastic raw materials, compostable plastics, and biodegradable plastic. Thus, a broader range of entities are covered under this term, that is manufacturer. So earlier it was only the finished goods, but even the plastic raw material, compostable plastic, and biodegradable plastic, those manufacturers are also included under the scope. Okay. Next is certification requirement. Who is to certify the manufacturers? So the manufacturers here are allowed to produce carry bags and commodities from compostable or biodegradable plastics only. Okay, and then they must obtain a certificate from Central Pollution Control Board before marketing the product and selling their product. Okay, so here we need to understand the details of what Central Pollution Control Board is. We'll understand that in the upcoming slide. And then microplastic testing. This is yet another highlight of the rules. Microplastic testing, but this is a lacuna here. That is because these rules do not specify which chemical test can establish the absence of microplastic. So they have not specified which chemical test can be used for establishing the absence of microplastic. Moreover, the extent to which the microplastic must be reduced for elimination, that is also not specified here. Okay, so these are all the lacunae. Next, we need to distinguish between biodegradable plastic and compostable plastic. We were seeing these two terms in the rules. So here it is better to understand the difference between the compostable plastic and biodegradable plastic. Already we understood what biodegradable plastic is. That is those materials which is capable of degradation by biological process in specific environments such as soil or landfill. So the environments here are soil and landfill, but here the environment is the conditions of an industrial composting plant or industrial anaerobic digestion plant with subsequent composting step. All these has to be there for compostable plastic. Next is biodegradation process. It depends on factors like temperature, presence of microorganisms in soil or landfill, nutrients, oxygen and moisture. Okay, and then here this compostable plastic reduces the waste from specific applications like takeout containers. There will be takeout containers, and from that, to reduce the takeout containers, we can go for compostable plastic. Next is it can reduce reliance on fossil fuels if made from bio-based sources. That is also there. Moreover, if it is not properly managed, that is biodegradable process is not properly managed, then it may not biodegrade as intended, and then it will lead to environmental damage also. Similarly, if this is not composted in appropriate conditions, then it can have the same consequence as non-biodegradable plastic. That is also there, and thus it will contribute to plastic pollution also. So it has to be managed, and then composting has to be done in appropriate conditions. So creating appropriate conditions is very important in compostable plastic. That is what our takeaway here is. Next is, these are all the plastics, different types of plastics that are recyclable. Okay, 1, 2, 3, 4, 5, 6 and 7. This is how they are given the name. Okay, resin code. One is polyethylene terephthalate, PET, and then high density polyethylene, polyvinyl chloride, low density polyethylene, propylene, polystyrene and others. You must have to remember this order and also the numbers for each of the plastic types that are there, and then examples are also important. Okay, you can have a look at it. Next is, as we discussed, we'll be discussing about Central Pollution Control Board. This Central Pollution Control Board was constituted in 1974 under Water Prevention and Control of Pollution Act 1974. This can be a potential question. Already this was asked in one of the prelims examination of UPSC. And then this Central Pollution Control Board was entrusted with the powers and functions under AIR Act, that is Air Prevention and Control of Pollution Act of 1981, and it serves as a field formation and provides technical services to Ministry of Environment and Forest. And the principal functions of Central Pollution Control Board include promoting cleanliness of streams and wells, improving air quality, and preventing, controlling, or abating water and air pollution. So they are solely responsible for water pollution and air pollution. Central Pollution Control Board. Okay, so this is what we need to understand from this particular topic. The topic that we are going to discuss now is Global E-Waste Monitor 2024. What is it? Let us get into the details and who has released it. Recently, United Nations Institute for Training and Research, UNITAR, has released Global E-Waste Monitor 2024, which states that the world's generation of electronic waste, that is e-waste, is rising 5 times faster than documented e-waste recycling. So we are not recycling but generating more and more of e-waste. That is what the concern is from this report. And what is this UNITAR? That is United Nations Institute for Training and Research. It is actually a training arm of United Nations which helps governments, organizations and individuals to overcome certain global challenges that are faced. Moreover, it offers learning events, solutions like workshop, seminars, conference, public lectures and online courses, and it also provides organizational advisory services, conference and retreat facilitations, and then online learning solutions. All these are made available under UNITAR, that is United Nations Institute for Training and Research. Now let us get into the details of Global E-Waste Monitor 2024. The key highlights or the findings of this. Before understanding the details of the highlights, we need to know what e-waste is. Okay, so what is e-waste? Electronic waste, which is a generic term to describe all types of old, end of life or discarded electrical or electronic equipment like household application, office information and communication equipment, etc. Okay, and then e-waste contains numerous toxic chemicals which includes metals like lead, cadmium, mercury and nickel. That is why it becomes a problem. Okay, moreover, what is the status in India? India recently ranks as third. Okay, currently it is third among the largest generators of e-waste globally, next to China and USA. So first comes China, next USA, and then comes India. Okay, we are generating a lot of e-waste, and then the volume of e-waste in India has witnessed significant surge to 1.6 million tons in the year 21-22. Okay, now let us get into the details of the highlights of the report. First thing that we have to note is e-waste generation trends, how it is generating in different parts of the world. One is there is a significant increase in global e-waste generation, that it has increased from 34 billion kilogram in 2010 to 62 billion kilogram in the year 2022, and this trend is projected to continue to reach 82 billion kilogram in the year 2030. And of this 62 in the year 2022, 62 billion kilogram, only 13.8 billion kilogram is documented as formally collected and recycled in environmentally sound manner. So only 13.8 out of the 62 billion kilogram is recycled. The rest is not recycled. That is the problem that we are facing here. Moreover, this 62 billion kilogram of e-waste include different parts or components like metals, plastics, and other materials like minerals, glass, composite material and other things. Okay, this is also important. What else do we have to know? What are all the drivers of e-waste generation here? There must be certain drivers here. So the drivers here are technological progress. So as technology progresses, yesterday's products are obsolete. Okay, we are not using it. That is one major factor for e-waste generation. Moreover, higher consumption rates are also there. A person will be using a lot of electronic products. Okay, and then as there is an updation, he will go for the next product. Okay, so there is higher consumption rates and limited repair option is also there. So earlier, when a product is not working properly, then they go for repair. But now, no, they throw it away, okay, and buy a new one. So limited repair options and short product life cycle is also another problem. This is to do with the design of the product and then growing electronification. Similar to this point and this point is linked. Technological progress and growing electronification. So as technology progresses, we are heading towards electronification. Every other thing that we see around us will be electronified. Okay, so this will lead to more e-waste generation and inadequate e-waste management infrastructure. Okay, e-waste is being generated, but then to manage e-waste, we need a robust infrastructure which is not there. Okay, which has to be developed. Next is informal recycling sector. We have recycling sector, but then that sector is being informal here. So a significant portion of e-waste both in high and upper middle income countries as well as in low and lower middle income countries is handled by informal sector due to inadequate formal e-waste management infrastructure. This point. Okay. What else do we have to understand? The environmental and health impacts of e-waste. Okay. So improper management of e-waste like informal recycling practices might lead to release of hazardous substances like mercury, plastic containing brominated flame retardants. These pollutants are being introduced into the environment, thus posing direct and severe impact on both environment as well as human health. Okay, and what is this brominated flame retardants? These are actually chemical compounds which are containing bromine, which is added to materials to inhibit or suppress the ignition and spread of fires. Okay, so they are actually added for a good purpose, but then they are toxic. That is the problem here. So they work by interfering with the combustion process, reducing the flammability of the material and slowing down the rate at which the flame spreads. So they have been designed for a good purpose, but then when they release into the environment, then that becomes a problem. Okay, when they release into environment as e-waste, then it becomes a problem. So globally, in a year, 58,000 kilogram of mercury and 45 million kilogram of this plastics containing brominated flame retardants is released every year. Okay, so this is to be noted. There is a regional disparity with respect to e-waste generation. That is also with respect to e-waste recycling. Okay, let us understand that. Europe has the highest rate of documented formal collection and recycling of e-waste, that is 42.8% of the global total. 42.8% is 42.8% of recycling is done by Europe. Next is Africa. Let us understand the disparity here. So Africa here struggles with low recycling rate of less than 1% despite generating lower amount of e-waste. They are generating lower amount of e-waste when compared to Europe, but then they are recycling very low, less than 1% is being recycled. But here Europe recycles 42.8%. And Asia, including India, generates a significant portion of global e-waste but has made limited advances in e-waste management. And countries in Asia generate almost half of the world's e-waste, that is 30 billion kilogram is being generated by Asian countries. The global total is itself 62 billion kilogram only. Okay, of that 32 billion kilogram is generated by Asian countries, but relatively few of them have enacted legislation or established clear e-waste collection targets. So they do not have e-waste collection targets, or they do not have e-waste related legislation, policy and other things. Okay, This is about the regional disparity that is there. Next is policy adoptions. Okay, so 81 countries have adopted e-waste policy legislation or regulation, and 67